Hello students, welcome to my channel Biochemics with Ajay Aminar. Here in this video, I'm going to discuss a few numericals from a chapter Motion from grade 9 physics, and a question and answers are discussed clearly. If you have any doubts and queries, you can send a message to me and I will clarify that. I think all of you will make use of this opportunity and get benefited out of it. After watching, please like this video, share it, and subscribe it. Thank you. Have a nice day. Now, children, we will discuss few numericals here from the chapter Motion. Here is your first question. An object has moved through a distance. Can it have zero displacement? This is your question. If it is so, support your answer with an example. See, dear students, here in the question it is given an object is moving and it covers certain distance. After covering distance, can its displacement zero or not? That we have to explain here. See, if any object is moving in a rectilinear motion or straight direction, its distance and displacement will be equal. The same object, after reaching certain distance, if it comes back to its starting point, its distance will be doubled, but its displacement will be zero. We have learned that displacement is nothing but the shortest distance between starting point and ending point. If the starting point and ending point of an object is same, then its displacement is zero. Now we'll see the answer. Yes, the object, though it is moving through a distance, can have zero displacement. Let's see an example. If a car travels a distance from point A to point B and reaches to the same point A, that means a car is started at point A. After some time, it reached point B, and again it comes back to its initial position, starting point A. Its distance will be doubled, but its displacement is zero because it started from point A and reached to point A again. So if the starting point and ending points are same, its displacement is zero. Now the second question. A farmer moving along the boundary of a square field of side 10 meters in 40 seconds, what will be the magnitude of displacement of the farmer at the end of 20 minutes, 2 minutes and 20 seconds from his initial position? Now let's try to understand this question with the help of a picture here. If you see this picture, here it is in the question it is mentioned as a square field. A farmer has a square field exactly. Square field means all sides are equal length. Here all sides are given, each side is given as 10 meters, and he covered a boundary, that means all sides he covered. For that he has taken 40 seconds of time. Then what will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? Now he started from A. From A to B he covered 10 meters, B to C 10 meters, C to D 10 meters, and D to A 10 meters. In one round in one round he covers 40 meters of length, full length, and he reached his initial position. Per round he finished 40 meters of distance here. To finish that 40 meters of distance he has taken 40 seconds, right? Like that he traveled for about 2 minutes and 20 seconds. After 2 minutes and 20 seconds he stopped his journey, and now at this time what is his displacement from his starting point? That's what we have to calculate. Now let's see given data. Side of the given square field is given as 10 meters. Hence, the perimeter of a square, that means a boundary of a square, is 40 meters. Now, time taken by the farmer to cover the boundary of 40 meters is equal to 40 seconds. Okay? Now, that means his speed is 1 meters per second. That means for every second he traveled 1 meters of distance. Now, distance covered by the farmer in 2 minutes 20 seconds. That's exactly 140 seconds. 2 minutes 120 seconds and 20 seconds 140 seconds. And moreover his speed is 1 meter per second. To cover 140 meters he has taken 140 seconds, since his speed is 1 meter per second. That means in 140 seconds of time he covers 140 meters of distance. But the actual distance of the square field is, actual length of the square field is 40 meters. That we have to remember here. Now, so the total number of rounds taken by the farmer to cover the total distance of 140 meters. Actual distance is 40 meters, but he covered 140 meters. To cover that 140 meters of distance, how many rounds he has to travel? That's what we have to find out. Now, total distance he covered upon perimeter of the square field. Here total distance is 140 meters and perimeter is 40 meters. Then you will get a 3 by 3.5 rounds he has taken, 3.5. That means at the end of 2 minutes 20 seconds he finished 3.5 rounds. At this point, let us consider the farmer is at point C from the origin A. That means if farmer starts at point A, he goes to point B, from there to point C, point D, and finally to point A. If he comes to point A, he covers 140 meters of distance. But the total distance given here is 140 meters. That means how many rounds he has to go? He has to go 3.5 rounds. 3 full rounds he has completed, and the fourth round is half he finished by the time. Right? Now, therefore, from Pythagoras theorem, the displacement we have in the question, it is given what is his displacement from his initial position. Here we have to use Pythagoras theorem, that is equal to, that is AC square is equal to AB square plus AC square. Here AB square equal to 10 square, BC square equal to 10 square. Here S equal to displacement equal to root 10 square plus 10 square. That gives you 10 root 2. If you simplify this value, you will get the displacement of farmer from his initial position is 14.14 meters. 14.14 meters. But the total distance covered by him is almost how many? each round 40 meters, 3 rounds 340 is 120 meters, and a half a round 20 meters. 140 meters he covered distance, but his displacement is just 14.14 meter. Since we know that displacement is the shortest distance between starting point and ending point. Here starting point is A and ending point is C. Next question. Which of the following is true for displacement? The first one is displacement cannot be zero. That is the first statement here. And second statement is its magnitude is greater than the distance traveled by the object. Children, we know that displacement can be zero. Can be zero. Already we learned that one, because if starting point and ending point are same, displacement of an object is zero and its magnitude is greater than the distance. We have to remember one thing here: the displacement, the magnitude of displacement never be greater than distance. It may either equal to distance or lesser than the distance of object. Now let's see answer. Here both the statements are false. Both the statements are false. We'll see the reason. The first one, because the displacement of an object which travels a certain distance and comes back to its initial position is zero. So, if the starting point and ending point of an object is zero, is same, the displacement of object will be zero. And second statement also false, because the displacement of an object can be equal to distance, but it never greater than the distance traveled by an object. Now we'll see one more. A difference is between speed and velocity. Now we'll see one by one point. What is velocity? Velocity can be defined as the rate at which an object changes position in a certain direction. If you say an object is moving with particular speed to a particular direction, this is called velocity of an object. It's called velocity of an object. Now speed, the rate at which an object covers a certain distance, is known as speed. Here in speed there is no mentioning of direction. No mentioning of direction, only some magnitude of distance is given. The rate at which an object covers a certain distance is known as speed. But in velocity, here the rate at which an object changes its position in a certain direction, in a particular direction. The second point, the velocity of the object changes with change in direction. Therefore, the object must follow one direction. For example, now third point we'll see a vector quantity. Velocity is vector quantity. Vector quantity is a physical quantity that has both magnitude as well as direction. Such kind of physical quantity is called vector quantity. Since velocity has both magnitude as well as direction, it comes under vector quantity. Now speed is a scalar quantity, since which has only magnitude of length, no direction, so it is scalar quantity. The fourth point, velocity can be zero, it can be negative or positive. Velocity can be zero if there is no change in direction or something. direction, no velocity. Velocity can be zero. It can be, if a velocity, a speed rate decreases, that is negative. It increases, that's positive. Here speed can never be negative or zero. Speed always positive. It can be negative or zero. So these are the differences between speed and velocity. Next question. Under what conditions is the magnitude of average velocity of an object equal to its average speed? So here question is about in which condition, in which case average velocity is equal to average speed. Whether their speed, is it possible for average velocity to equal to average speed? Now let's see. Since average speed is the total distance traveled in a total time taken and velocity is the total displacement in the time taken, the magnitude of average velocity and average speed will be the same when the total distance traveled is equal to the displacement. Yeah, of course, here total average velocity will be equal to average speed, but there is a condition. When our total distance traveled is equal to the displacement, in this case average velocity can be equal to average speed. Now next question. What does the odometer of an automobile measure? Odometer. We know that a speedometer that measures speed of an object or vehicle. Odometer that measures distance of automobile or vehicle. An odometer or odograph is a device that measures the distance traveled by an automobile based on the perimeter of the wheel as the wheel rotates. So here this odometer that connects to the wheel, that means that counts number of rotations made by a wheel, and finally it gives us the distance traveled by that particular vehicle. So odometer measures distance traveled by the vehicle. Now next question. What does the path of an object look like when it is in uniform motion? If an object is moving in a uniform motion, what does the path of an object look like when it is in uniform motion? So here we have one instance. An object is moving in a uniform motion. Uniform motion means if an object moves with constant speed without changing any speed, that is said to be object is in uniform motion. So if an object is in uniform motion, how the path of an object look like? That is the question. The path of an object in uniform motion is straight line. Straight line. That means the slope of a graph, if it is straight line, that indicates an object is moving with uniform speed. If slope is not straight, if it is curved, we can understand that an object is moving in non-uniform motion. Right? Now, next question is, during an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? The signal, the signal travels at the speed of light, that is 3 times 10 to the power of 8 meters per second. Here is an experiment is being conducted. Here, a signal from spaceship reached the ground station. There is a ground station on Earth. It's receiving some signals from the spaceship which is in the space, and The time taken to reach that signal to the ground station is given here as 5 minutes, and the speed of that signal also given as 3 times 10 power 8 meters per second. So we have two quantities here. One is time is given, second thing is speed is given, and we are asked to calculate the distance between the spaceship and the ground station, that is to be calculated here. Now let's see how to calculate a given data. See, the signal travels in a straight line, so it's in a uniform motion, or you can say rectilinear motion. The distance between the spaceship and the ground station is equal to the total distance traveled by the signal. That means the distance between spaceship and ground, that is the total distance traveled by the signal. Time is given here as 5 minutes, that means 300 seconds. We have to convert time into seconds since speed is given in meters per second. So time also should be converted into seconds. Speed of the object is given 3 times 10 power 8 meters per second. Therefore, the total distance, we know the distance formula, speed into time. Here speed is given as 3 into 10 power 8 meters per second times 300 seconds time. That is equal to 9 into 10 power 10 meters. This is the distance traveled by a signal from spaceship to reach ground station. Now, when will you say a body is in uniform acceleration and non-uniform acceleration? How can we say a body is in uniform acceleration? We know acceleration means rate of change of velocity per time. Rate of change in velocity per time is called acceleration. And when we say object is in uniform acceleration and object is in non-uniform acceleration, here we have to give two examples to solve this question. Answer. Now you see uniform acceleration. When an object is traveling in a straight line with an increase in velocity at equal intervals of time, at equal interval of time, then the object is said to be in uniform acceleration. That means the velocity should be increased at regular equal intervals of time. That means, for example, if velocity increases for every 1 minute, every month, for every 60 seconds, that means that acceleration is in is uniform acceleration. That means change in velocity should be occurred at regular equal intervals of time. Acceleration means there should be change in velocity per time. Change in velocity per time. If this change occurs at regular or equal intervals of time, then the object is said to be in uniform acceleration. Example, the free falling of an object is an example of uniform acceleration. That means if you drop any stone or something from the top floor to the ground floor, initially when you leave that stone, the speed, when the stone is in your hand, its speed, its velocity, acceleration is zero. If you leave it gradually, its speed increases, thereby its velocity increases, and in velocity increases, thereafter acceleration also increases before it reaching the ground. Now we'll see non-uniform acceleration. When an object is traveling with an increase in velocity but not at equal intervals of time, So we know that acceleration means there should be either an increase or decrease. There should be as an increase in its velocity. If this increase in velocity happens at equal intervals of time, that is uniform acceleration. But if this change in velocity doesn't occur at equal intervals of time, it's known as non-uniform acceleration, right? Now, example, bus moving or leaving from the bus stop is an example of non-uniform acceleration. For example, if you take any vehicle like train, bus or something, initially they start slowly, then they pick up some speed. After that, they apply some brakes because of speed breakers, because of signals, and because of some, if any animals come into their way, they have to apply brakes, they have to decrease velocity. Then the bus is not moving with acceleration at equal intervals of time. Sometimes velocity is decreasing, sometimes velocity is increasing. So this is example of non-uniform acceleration. Now, next question is, a bus decreases its speed from 80 kilometers per hour to 60 kilometers per hour in time 5 seconds. Find the acceleration of the bus. So here bus is moving, it decreases its speed. It's actually moving at 80 kilometers per hour, and suddenly maybe a driver may apply some brake. Its target is to decrease the speed to 60 kilometers per hour. To bring that speed from 80 kilometers per hour to 60 kilometers per hour, time taken is 5 seconds given here. Now find the acceleration of the bus. Right. Now you'll see the data. Given the initial velocity is given u as 80 kilometers per hour. So whenever speed is given kilometers per hour, you have to, but time is given in, since time is given in seconds, we have to convert kilometers per hour to meters per second. So 80 kilometers per hour is equal to 80,000 meters per 1 hour is equal to 3,600 seconds. If you simplify, you will get 22.22 meters per second, meters per second, meter second inverse. The final velocity, its target is 60 kilometers per hour. That means if you convert into meters per second, 60,000 meters upon 3,600 seconds, that is equal to 16.66 meter second inverse. So we converted final velocity as well as initial velocity into meter per second. Now time given, time frame, that is equal to 5 seconds. In 5 seconds, 80 kilometers per hour speed is brought to 60 kilometers per hour speed. Therefore, acceleration formula, final velocity minus initial velocity upon time. Here final velocity, it is given as 16.66 meters per second minus initial velocity 22.22 meters per second upon 5 seconds. If you simplify this one, finally you will get minus 1.112 meter per second inverse square or meter per second square, since SI unit of acceleration is meter per second square. Therefore, the total acceleration of the bus is negative it is given as negative minus 1.112 meter per second square. Because speed is reduced, so when speed decreases, uh, that is shown as negative. When speed increased, it is shown as positive acceleration. It can be noted that the negative sign indicates that velocity of the bus is decreasing because the driver applied brake over there. Next question. A train starting from a railway station and moving with uniform acceleration attain a speed 40 kilometers per hour in 10 minutes. A train starts from a railway station. That means from zero speed, zero velocity, and from zero acceleration. It starts from zero and it's moving with acceleration to attain a speed of 40 kilometers per hour in 10 minutes. So here acceleration speed is given, time also given. We have to calculate its acceleration. Remember here train starts from 0 kilometers per hour speed to the 40 kilometers per hour. That means speed increases, velocity increases, and rate of velocity also increases. That means acceleration happened. Now let's see the answer here. A given data initial velocity is given 0 because train starts from rest. Final velocity is given as 40 kilometers per hour, and if you convert this into kilometers per hour into meters per second, we have a formula. A given speed in kilometers per hour times 5 by 18, that we know how 5 by 18 comes, and final velocity will come as 11.11 bar meters per second. Now time taken to attain that velocity 10 minutes. If you convert 10 minutes into seconds, it's 600 seconds. Now from this data we have to find out acceleration of the train. Now we'll consider the formula of acceleration. Initial velocity, final velocity equal to v equal to u plus 80. Here u is initial velocity, a is acceleration, t is time. From this formula we have to find out acceleration. If you substitute all the values in this formula, that is final velocity 11.11 meters per second, that equal to u equal to 0 meters per second, plus a we have to calculate, and times time is given, that is 600 seconds. Now that equal to 11.11 is equal to 600 a acceleration. If you multiply 600 a, and finally acceleration is given as 11.11 upon 600, that gives you finally 0.0185 meter per second square. So the acceleration of train at speed of 40 kilometers per hour in 10 minutes is 0.0185 meters per second square. It's a positive acceleration since its velocity is increasing here. So my dear students, I think we have covered almost 11 questions here, and just go through them, practice them, and prepare for your upcoming examinations. Thank you. All the best.